Should be recording now.
Cool. Okay, welcome to the September Northwest C++ user group meeting. Tonight what we're going to do is we've got, so far, a collection of 3 presenters to do some lightning talks. So this is going to be totally ad hoc and a lot less formal than we normally do. But it'll be something different. Also, let me know if you guys like this. Part of the reason I put this together was I had one I wanted to do, a topic that was not big enough for a full presentation. Matter of fact, it might not even be quite big enough for a solid lightning talk. But I wanted to provide a forum where, you know, smaller topics could get in. If somebody wants to do a presentation but they don't have an idea for a big one, you know, it gives a good opportunity for that. I'm kind of hoping we'll try to maybe do this once a year if there's enough interest, and possibly right before CPPCon. So people who want to practice a lightning talk that they're going to possibly give at CPPCon or any other conference, have a forum to do that too. And it's a good way to, you know, start speaking. You know, very short, 5-10 minute type of thing, and you know, get your feet a little bit wet. Which brings me to the next topic is CPPCon. CPPCon is next month. From, I don't have the dates up. From October 24th to the 29th. Note that we will not be having a user group meeting next month. So we've traditionally kind of not done that when CPPCon is going on, because a lot of us tend to travel to CPPCon, but even, well, CPPCon's hybrid now this year, there's still a lot going on right about that time. Let's see. I think that's all the updates I've got. We've got 3 presenters tonight. Peter Williamson talking about C++17, the compile time if statement. I'm going to go ahead and talk about toward less magical numbers. And Chris Williamson, the error that shouldn't be. I'm going to ask one more time before we dive in. Does anybody else have a talk and want to get on the list to start? Okay. Oops, Scott, I cannot hear you. Oops. Okay. Well, we'll dive in with that. I don't know, Peter, do you want to go first?
Sure, I'm happy to go first. It just takes a few seconds for unmute to happen. So I need to present my slides, so let me try the UI. Lloyd, I think you may have to approve it when I try to present.
Oh, and just a sec. Chris, I see your hand up. Did you have something you wanted to say?
No, sorry.
Okay, no worries.
Thing.
Okay, go for it, Peter.
Okay, do you see my slides? Is it asking
No,
you to approve them?
Robin,
do you see my slides? Is it asking you to approve them?
Not yet.
All right,
Maybe
let
it
me
takes
try.
a few dozens of seconds to for them to appear on the screen.
I'm opening the share tray and clicking desktop or window.
Yeah, let me
I'm going to click tab. I'm hitting share. Does that show up for people?
Yep, it's starting.
Yet. Yes, it is.
Awesome.
There you go.
So today, from my upcoming remedial C++17 talk, which should happen in only about another year and a half now, we're going to talk about the compile time if statement. So the first thing I wanted to do is to say thanks to Walter, because this idea actually came from D. So this is one of the ideas that's gone from D into C++. So what does it do? As it says, it calculates the if, then, else at compile time. So let's give you an example. This is from Josuttis' nice book on C++17. So we've got a template that takes a type name that's a string, and then we can do a const expr if. So this would have to be something that's constant, not computed on any values that are found at runtime. And if it's the same, then we'll return x. If it's an arithmetic type, then we'll convert the arithmetic type to string. Otherwise, we will call the standard string constructor and just hope that it happens to work. So this allows you to make So why would we do this? This allows you to make templates that would otherwise never compile like the example. So it could be used for perfect forwarding. So when you have a reference, you want to make sure you get a reference. If you have an R value reference, you want to make sure you get an R value reference. So sometimes when you're copying and moving things, you want to make sure that the reference quantifiers don't get stripped, and that's what we call perfect forwarding. So one use of the compile time if is to get perfect forwarding for return values. It can be helpful for doing a tag dispatch. You have a dispatch-based systems. And we can also use it outside templates to reduce the code size a little bit more. So there's some gotchas to know about the compile time if. First, the unused branches still have to be syntactically correct, and it could affect the return type. So the compiler's got to make its own guesses, and it relies on syntactical correctness, even of branches that were not being taken at compile time. Second, the return type could be affected by the else, even if it's the then part that returns. So the compiler, when it's compiling this the first time, has to look at all the types of the different things, and it may make some inferences based on the types that it sees. And the third thing to know is that it does not have a short circuit evaluation like the regular if. So the regular if, we're all used to saying if pointer and pointer dash something that it points to. Here we can't do that because if the pointer is null, it'll still try to evaluate the pointer and thing that it points to. And that is all I have.
May I ask a question?
Go for it.
Can you please show the firstmost line?
Put the first slide back on? Sure,
Yes.
just a second. Let me reshare the tab. See, is that showing up for people?
Not yet.
Nope. Okay, let me try the other way. Oh, no, I can't because I've closed that tab. I'll have to reload it. Sorry. But all the first slide said was thanks to Walter, and it works similarly. I think what you want to see is the next slide that had the big example on it.
Yes.
All right, I'm sorry, but I'm on a low-powered Chromebook, and to close the presentation, I closed the tab. It's going to take a while for me to reload that. So if you can hold your question, maybe we should let the next presenter go, and I'll try and get it reloaded and have it reloaded by the time the next presenter is done.
No problem.
Yep, and we got plenty of time tonight, folks, so no worries on that. Robert, I see your hand up.
Yes, your last comment about the short circuiting, and then you gave an example, so if you had like a null pointer, but wouldn't that be a runtime evaluation? How can it evaluate the contents of a pointer at compile time?
You're absolutely right. That was an example based on a runtime if, not based on a compile time if. That's just the standard way that I think about short circuit evaluation, is it lets me take that particular shortcut. So that was not a good example. I apologize for that, but I think it gets the point across that you have to be prepared for both branches to be evaluated.
Okay. Can you think of a time when you might have something that would fail short circuiting during compile time sometimes and not all the time, or?
Not off the top of my head. I can go back and check the source material that I found, see if there's any examples and get back to you, but that's the best I can do.
Okay.
Yeah, so I can think of one off the top of my head that I've done actually. It wasn't a pre-processing type thing, but it was a construct we had with live code. Essentially, when you have an enable and a command, where you both have to be true, you'll check the enable and then the command or something like that, where you've got essentially a resulting state contained in two variables. That would probably get what you're looking at, Peter. But
in this case, we might not have the variables because it's compile time. So I think we need to look a little bit deeper to understand an actual case where this would bite you.
Yeah. Okay, other questions for Peter? Okay. So I'm going to go, I'll pick up the next slot here. Going. Okay, can you guys see that?
Yes.
Yes.
So I'm going to talk about toward less magical magic numbers. So in the dark times, we realize that kind of goes with the theme I picked. That was not planned, just coincidental. So in the dark times, we tended to represent constants like this, basically a type, a variable name, and just a value. And there's a whole lot wrong with this. We'll get into that in a moment, but that's, decades ago, that's kind of what you did. You just assigned a variable a number and called it good. So eventually we started calling this a magic number. It's just a number. It has to be correct for the program to work. And traditionally at that point, there really wasn't a whole lot of information, added to it. In pretty short order, it was recognized this is a source of a lot of bugs and a lot of confusion. So we started doing this. Let's put a comment on the top. So this is the natural log of 1, or e to the first. This is what the number is, or what meaning it has in the program. And then we put a constant in front of it. So now we know it's a constant. It's not just some variable running around. And we'd give it a name. I just chose E, because that's typically what this is. So this is better. But for many applications, it still isn't good enough. Now, if you look at code today, this is generally what you see. You see some type of magic number that's defined with a name and a const and a comment. But there's still a lot of information about this number that's missing. Where did this number come from? So in aerospace in particular, you've got traceability requirements. So if you pick up a number and just, where did the number come from? What's your reference? Scientific computing would also have a requirement like this. Why this particular precision? If you do algorithms that are iterative and like converge to they're targeting a solution, they iterate toward that solution, the precision that you put in the number actually can affect the outcome quite greatly. And then, is there a traceability requirement? Does this number come from a particular requirement? Again, more information about the number. So even when it's not formally required, having more information makes the number less magical. So I'm proposing, for these additional, when you need it, not all the time, but when you need it, think about adding things like the source. So I got this particular number off of Wikipedia, and there's the URL to the page I got it from. 12 decimal places are required for algorithm foo. Okay, I kind of made that up, obviously. But depending on the algorithm that you're using, 8 digits, which is what people kind of normally tend to do because calculators tend to do it, that actually is not enough. You can get the wrong answer or no answer at all, depending on your algorithm. And then per requirement, ABC, blah, blah, blah. That would trace back to your formal requirements. In aerospace, you have documents that that have these things listed in them. And you'd want to trace and link that back to the requirement. And then, of course, you have the constant, just like before. But what if it's just a number that you made up? Well, then say so. And for that, I typically use the flag developer discretion. Sometimes it really is just a number. I just made this random number up for no particular reason. And by saying that, you let the reader know this number is made up, don't go trying to put more meaning to it than there really is. This actually has real-world implications. This little talk came from an actual problem I ran into. I won't get into the full details of it, but it was an actual project in aerospace. And for people who haven't worked in aerospace, you typically have two teams working together. You have, in this case, the flight software team, or the primary product, the team building the primary product. And then you have a second team, which is typically called IB&V, Independent Verification and Validation. Their job is to make sure that the primary product is right. And oftentimes, they do that by re-implementing the algorithm. So this is the paradigm we were working in. We had a number that had two different levels of precision. One literally had 8 digits of precision. One had 12 digits of precision. And of course, when you compare the answers, it was an iterative algorithm. When you compare the answers of these two, the resulting was vastly different. I believe this was a distance calculation, and it resulted in a difference of over 100 miles in the calculation. It was huge because the iterative algorithm magnified that precision difference. It actually only took us a few minutes to find the difference. We just looked at the two code bases. Oh, somebody's got 8 digits here, they've got 12 over here. It actually took us a month to sort out which number was correct. And it wasn't just go with the more precision, because that wasn't a clear answer. Did somebody make an assumption? Where did these numbers come from? This was actually a piece of code that was involved in the safety systems. So you couldn't just make it up or say, this is good enough. You had to know all of the detail of where this number came from, why it was what it was, and basically what I've shown in the prior slides. So that's what I wanted to talk about. Any questions?
Hey, Lloyd, everything you said, absolutely correct. I have a suggestion for you to combine your idea with the previous talk and do a const expert expression at compile time that actually computes a natural log of 1. And that way, compile time computes it to the maximum number of digits available and stuffs it in there.
So let me address that one for just a second, because sometimes actually putting the maximum number of digits is not what you want to do either. Because sometimes you have other assumptions that contradict that. And of course, I didn't get together with Peter beforehand, so we didn't compare notes. But yeah, okay. Robert, also see your hand up.
Yeah, I had kind of a similar thought. I've seen programs where there's a giant constants file that everybody uses. And maybe it's even an official Microsoft header file. And then a lot of times you might use a constant like 2pi, and that would certainly be one that you might want to compute at compile time instead of computing it yourself and then typing in the actual value.
Yeah, so I actually just had a thought on that as well. At least the stuff I've been working in lately, you actually would not want to compute this at compile time. And there's a specific reason for that. When you compute it at compile time, the value is dependent on the compiler and the way it's doing the calculations. Not all compilers and not all math libraries give you the same answer, even for the same formula. Matter of fact, I actually ran into this problem with a Microsoft product at one point, where it was the same compiler, it was Visual Studio, to name names, sorry, but the debug library and the release library actually gave different answers. I was, and they were vastly different. I was doing something a little bit creative, where I was using overflows and a couple other things to kind of generate a pseudo-random number type of thing. And the answers were completely different. So that's something to be aware of. In this particular application where you actually need to know what the value is and you need to reference it to external platforms, you probably just want the real number in there rather than trying to compute it on the fly.
So if you had a number, a magic number that was not a mathematical known constant, but some kind of number that you needed to use in more than one place, you certainly wouldn't want that number duplicated in different places of the program.
Right.
So.
Yeah, and I've actually done the big header file with all constants in it, and some projects that seems to be okay, and some projects it doesn't. I've seen that done both ways. This particular value had to do with that we ran across had to do with the curvature of the Earth. So it was not something that is even there really isn't a purely correct value for it. There's a lot of assumptions that go into how that number is calculated. And that's actually part of what we were seeing in this particular problem. All of these assumptions boiled to the surface, and the only assumption that was really different when we chased it all down was somebody rounded it off and somebody else didn't. But there was a lot that goes into that number. Okay, other comments, questions? Ready for the next speaker? You're up. So Chris is going to be talking about the error that shouldn't be.
Okay, isn't that lovely? It starts sharing and it moves my screen on me. There. Okay, are you seeing my slide?
Yep.
Yes.
Okay. The error that shouldn't be. And so you've all seen code like this, and first of all, ignore that the logic on this makes absolutely no sense, because you know you would never hit the equals. The if equals wouldn't be important, because if it's not less than or not greater than, it has to be equals. You'd never hit the else. I wanted all these just to show the points of comparison about how the assembler works. And of course, if you go to compile it, you get signed unsigned mismatch, because you got an int and a uint. And that's because, as we all know, even if you have a 32-bit number, your signed int goes from minus 2 to the 31st to positive 2 to the 31st, where an unsigned goes from 0 to 2 to the 32nd, minus 1 technically. Rainier Grimm recently showed this issue on his modernist CPPcon.com site, and showing using the less than and greater than, a couple different combinations with a signed and an unsigned. And here's the output that you get from this, which is not true, because there's some internal errors that happen because of the bad way that comparisons work. So because there's a known flaw with using compilers that use signed and unsigned, the standard template library has been smart enough to decide we better provide a comparison for this. We compare for if they're equal, and this is for signed and unsigned, and not equal, less than, greater than, less than or equal to. I say you shouldn't have to go out and spell it out when we have built-in operators for this. This is what the assembler is that's being generated, and this is very crude pseudocode assembler. But basically, what every comparison does between two values, it does a compare between A and B. And it would actually really have loaded a registers and compare registers with an offset and indirect. But what a compare is actually doing is it takes A minus B and sets the internal processor bits. In this case, it's checking for a jump if not borrow. Borrow is also the inverse of carry. So if
Can
this
you
was...
show point with the mouse cursor?
I'm pointing on the wrong screen. Sorry. So the jump if not borrow jumps down to the label 1, and it does a comparison here. Jump if it tests to borrow, falls down and compares A and B. Jump if not equal, and it does each one of these if else's and jumps to the end all the way at the end. These are the processor flags that are getting set. Carry, parity, we don't care about. Overflow, we're not worried about. We mostly find useful for doing comparisons the carry flag, which is also known as the borrow. Zero flag if the result is 0, and the sign flag is if the top bit is positive or negative. Here's all the different flavors of the jumps that are available to you. And of course, a lot of them have equivalent or different names, but the same opcode that's actually generated. And so back to our comparison between a signed and an unsigned. If the numbers are between this range is the only case when you can actually truly compare them. But we know that if the signed number comes up with a negative result, the top bit of is signed is negative, that the signed number has to be less than any number that could be in the end, in the unsigned, and vice versa. Here on the signed, if the top bit is set, that means that this number has to be bigger than any number you could have in here. So by adding a little bit of logic, and this is only, the compiler could do this only when it knows it's mixing a signed and an unsigned. If it tested A, and test is the same, very similar to compare, but it does it better at setting certain flag bits, like the signed flag, or compare won't necessarily set the sign. So jump if it's signed, meaning if the sign flag is on, we know that it's a negative number. Therefore, A has to be less than B no matter what B is, so it jumps into the actual case here. The reverse test of comparing B or testing B sets a sign flag, which means the top bit is on, and which means anything in the top bit has to be bigger than A, than the sign. So it jumps down to here. And then we actually do the same comparison it was doing before, which is in the valid range and the overlap. And then it jumps down to the next else if. And it does a similar type of logic here, but because of which one was assigned and which one was the unsigned, the path of the bits is doing a slightly different thing. So if it's signed, if the signed flag is on for the signed, any negative number has to be smaller than any positive number, which is the uint. Therefore, this whole thing jumps around. And a similar logic for testing for B, if B is signed negative, and actually let me get my logic straight here. If it is in the upper half of the bank, it has to be bigger than any possible n, so it falls down. And by this series of cascading logic, this will handle, and the compiler could do this just by adding a couple extra assembly instructions for comparing signed and unsigned. And you would never see an error again for signed sign unsigned mismatch. Thank you. Questions?
So I have one comment on that. So could you just write overloaded versions of the comparison operators and just implement it as straight up C++ code?
If you're doing it on classes, yes. However, you are not allowed to have global overloads of intrinsic operators, of the comparisons operators.
Okay.
Yeah, and I wanted to do that and thought about that and said, well, I'll just write a template to do that and then wrap these the safe comparison.
Well, you could actually just, I didn't think of that, but you could just make a new name, right? Less than LT or something, and then overload that. I mean, if it's in your own code, right, and you care enough about it.
Yeah, but shouldn't the compiler do that? Every second grader knows that what a negative number is and what a positive number is and how to compare them, where they fall on the scale. When they got remember Mrs. Johnson's second grade class, and they had the number line above the chalkboard that half the people do their math by counting on it. But everybody knew where the negatives were and where the positives were and how to compare them. Why can't our compiler? And actually, one thing I failed to include in this is I blame early assembly people, because the comparison that they're doing is exactly what you do in assembly of how you compare two numbers. And you would have to know that they were both either signed or both unsigned. But the compiler will actually give you the wrong answer if you don't have the warning level turned up high enough. And so the very early compiler writers, because they were formerly assembly people, and actually the compilers were written in assembly, did just implemented that cookie cutter comparison of compare, branch not equal, compare, branch not borrow, or of carry or whatever. And whereas they still want to be so efficient and so fast, they don't want to put in the couple extra assembly instructions. And to me, it doesn't matter how fast you get there if the answer is wrong. Take the time, get the right answer. Other questions or comments?
Yeah, you're making me want to go back, and now I'm worried about all the code I've ever written because a lot of times I just wouldn't care whether I was comparing signed and unsigned, and I expected it to work.
Well, the cautionary tale there is there's two compiler switches you should always have on: the wall and where. The WALL turns all warning levels on, and WARE makes any warning an error. And you can never check in anything that has any warnings or errors, and therefore they'll get fixed. The bad thing that most people do is anytime they see that, they just cast one of the numbers to either a signed or an unsigned. And that's okay if you know you're in that narrow range of where your valid comparisons. But if you ever have the chance of being far off one side or the other, you could really screw up your number range.
Yeah, I was just thinking, Chris, I think this really traces back into C, where, just like you were saying, that, gets into the assembly. I was just thinking, if you were to actually implement this now,
that's the thing, yeah.
You'd be able to filter it on signed and unsigned, so you wouldn't break correctly written code. But I'm just wondering if you would if there's a way you could break incorrectly written code.
It would. It would actually show up errors, or it would fix errors that were working before because they were actually broken.
Yeah.
Which actually comes back to something the standards people do is they absolutely will not change something if there's any chance of breaking compatibility.
Right.
Which brings up a definition I have. You know what the definition of a feature is? Huh. It's a bug with seniority. Once it's been put out there, you can never fix it because people are depending on it.
Yep. I was just trying to think, is there a case of this where the quote unquote wrong answer would make the program work as expected. And I don't know, I'm pretty careful with signed and unsigned, so I can't think of anything off the top of my head.
Well, I could see that there are programs that are doing the wrong thing, causing, a domino of errors to happen that then later get caught and handled and then does the right thing. Whereas the right answer would have taken it down the correct path earlier and it wouldn't have been an issue. Or it was doing potentially the right thing for the wrong reason, or it might actually be calculating your number, and your convergence for your problem isn't going to happen, not because the numbers aren't exact, but because you're comparing negative and positives.
Yeah.
Signed and unsigned.
I'm just wondering, I wish we had a compiler person here, like maybe Walter or something else. It almost seems like this should be pushed up and, just go fix this. And fix it everywhere, because it's annoying, and the way you framed it, it's actually...
I mean, don't they usually have a flag like better floating point consistency, and at least with floating point, there's you have a choice of making it fast or making it like IEEE compliant, right? And so you make it a compiler flag, and you can make integers comparison a compiler flag too. That I'm going to do the good version that Chris suggests, or the old compatible version. Seems totally reasonable.
Yeah, that's probably what you'd have to do.
What it would probably actually take is the standards committee won't do it until some of the compiler vendors stand up and say, we've been doing it wrong all along. Here's a better way to do it, and actually implement it. And one thing that compiler implementers do is, like your exactness on the floating point, they always have flags or pragmas for disabling.
Yep.
Stuff like that. And if the compiler could actually look back and know that the number had been cast back and forth a few times, or where it came from, and what the possible actual valid range was, the optimizer could decide to skip that step because it knows the numbers, even though it's an assigned number, are never going to be negative, or they're never going to be extremely large uints.
The only other thing I can think of is I listened to a talk on CPP Cast. Probably 2 years ago now, and they were talking about how they, in addition to the backward compatibility, there's a concern around the numerical processing, because, and this blew my mind, C in particular, but C++ as well, wants to be compatible with platforms that do not necessarily represent negative numbers as 2's complement. And this particular talk was deprecating that feature. So they'd actually, I can't remember the name of the system, but they were saying, C and C++ are actually still compatible with with some piece of hardware that represents negative numbers in 1's complement.
Yeah,
and that may also throw another twist into this. The standards committee would have to look at.
Well, there is actually a proposal out there, and I'm not sure if it's been approved or if they're still looking at it, but that C++ will go entirely to its complement.
Yeah.
And throw away a little bit of legacy support. If it's a 30-year-old computer they're trying to run it on, chances are there's not a whole lot of new development happening for it.
Yeah, I think you were talking about the same proposal.
Yeah.
I am actually working at a place where they specifically have that, because apparently it's considered a security measure.
What?
Nobody knows how to program this thing. Therefore, no hackers.
Is that the?
It's also like if you're
complement machine.
Yeah.
Do you work with Brett?
Brett?
Yeah. Yeah. Okay. Yeah, because I interviewed out there about 5-10 years ago, and the PDP, what was it, 24, something like that?
PDP 10 architecture, I guess, except it's a Toad they call it a toad, and I just lost audio.
It's a 36-bit system, right?
Yeah.
Yeah. And if you actually looked up the assembly for it, it's out there, and you could hack it, but you'd have to know they were using your router, and that they wanted hacking on the L1 level.
Well, hacking isn't something I've ever had an interest in. But,
no, I know it is possible, but it makes it obfuscates the hardware. So the next best thing would be inventing your own CPU.
Mm-hmm.
So, okay, I think my time slice is up, though. Thank you, Lloyd.
Okay, well, thank you, everyone. We've got some time left. Does anybody have something they just want to bring up, chat, debate?
I have answers to the two questions I was asked earlier. If people would like them.
Thank you. Yes, go for it, Peter.
So first, I've just sent it to the chat. Here's an example of when you might actually use short circuit evaluation with a compile time if. So you've got a compile time if const expr, and the first half of the and is measuring whether it's actually an integer, and the second half is assuming that it's an integer and then making sure that it's less than 10. So in this case, if you're relying on the second half not being evaluated because the first half fails, even at a compile time, you could still end up with a problem. Secondly, I believe Robin wanted me to represent one of the slides. So I can quickly represent that slide so that Robin can ask his question. So let's see if I can get this to work correctly. Let's screen share. Click tab. Choose the tab. Click share. And hopefully people will see it.
I see it.
So Robin, can you tell me your question?
For me, it's shown still loading. So the firstmost line of code in the right part as string, opening angular brace, no closing angular brace, and closing parentheses. There's something feels like typo.
I think you are probably right. I typed this all in by hand. Just a second, I can find the place that I copied it from. Let's
It looks
see.
like instead of angular opening bracket, there should be opening parentheses after S string in front of T.
I think you are right. I will get it corrected before I present this again. Thank you for finding that for me, Robin.
Okay, thanks. That was my question.
In this case, with the if const expr, it is an absolute compile time decision. However, there are other flavors of const expr expressions that will sometimes be compile time, and if they can't always be compile time, they will actually be a runtime. And there is a way to check. I can't remember what it is though, but so just because you put const expr on something doesn't mean it will actually be compile time.
Same as with const expr constants. They might be evaluated at compile time and at runtime.
I think the key point is it both has to have the const expr and do have to have something that actually is a constant. And I think we're smart enough to know that.
Seems like in these cases, it's like you could get the same behavior without using const expr, right? Like I sort of always assume that the compiler, if it sees like an if false, that it's just going to remove that branch, right? And like since it's static, like this T is string. That's a thing that's. I mean, it will figure it out at compile time, and it's constant, either true or false, and it's just going to do the right thing, whether you put const expr there or not. But maybe I trust the optimizer too much.
So I just checked the books that I got this from, and they claim that if const expr is actually required if you want it to be treated as a compile time if statement. But you're right, there are places like if false where the compiler could in fact know that this is always going to be constant. or this is always going to be a certain branch.
Okay.
The if const expr has the added benefit of that doesn't actually have to depend on the optimizer. If const expr actually is like that code never existed and doesn't have to be optimized away. And I believe you can actually have things which are grammatically incorrect inside an if const expr if you know it's false. And it actually has to do that because if the X value that came in couldn't be converted to string, the middle return would actually fail and potentially the compiler would puke on it if it's not an arithmetic type. So if it were, say, some other string constant, you can't convert a string to a string or something else. But so it actually can get around grammatical errors where a normal if would actually have to be compilable code and then be optimized away.
Well, plus, you can use this for compile time table generation or whatever. You aren't stuck with just putting constants. You can use code. I may be stating the obvious. Sorry. Yeah,
with D++20 and even some of the stuff that's coming in 23 more, you can actually do compile time code that has loops in it, that does allocations in it, the const expr stuff, and it will actually generate all that code and then constify it. So you don't have to run it at runtime or at initialization time. It will happen in the compiler, and you'll basically build your tables then in the compiler, and then that value gets loaded into code as constant.
Very useful.
That definitely sounds very cool. I won't get another chance to learn about it for 3 more years, though, at the rate I'm going.
There's a couple CPPCon videos out there about that. Go back and look at last year's videos and just search across all for const expr. And there's a couple examples of some of those.
Oh, I'm sure I could find them. It's just that I am trying to learn C at a pace that's about 3 years or 4 or 5 years behind what's actually hit the mainstream for this whole remedial C++ business that I've been doing.
By the way, Peter, let me know when you're ready to give another one of those, and I'll get you on the roster.
Okay, it's about 1.5 years away at my current pace.
Okay, I'll cross you off then for this coming year.
That would be good.
Yeah, I like your remedial C++ talks because it's about the time you're talking about them is about the time stuff I'm typically doing, I can actually use it.
Yep, and that's the point. I wanted to bring it to people's attention right about the time their organization is actually willing to let them use it.
Yep. Yeah, that works out really, really, really well. Because by the time I go to CPPCon, I learn it. By the time I get to use it, I've forgotten it. And it's, hey, there's Peter. He'll remind me. Okay. Go ahead.
Yeah, my organization wouldn't let us use anything other than the original C++ for quite a few years, but then I got pulled off to do C# for several years, and so I missed learning all that advanced C++. So your remedial class was a great introductory class for me. I went and actually tried all those things to see how they worked. I liked it.
Thanks. So, Scott, you bring up an interesting question. This is a little off topic, but since we got a little time, just a general question to the group. How, on a typical project that you guys work on now, how many languages are in use on that given project?
Let me make sure
So let me qualify. So,
is that me, Scott, or a different Scott? Sorry.
No, I'm kind of addressing the entire group. This is kind of just a survey question because what I've noticed, a decade or so ago, you could take C or C++, and in a real-world application, write an entire project essentially with one language. What I'm noticing now, and these are somewhat distributed systems I'm working on as well, a typical project I'm working on right now involves C, C++, Rust, LabVIEW, and some Python. And it's just a trend I've noticed over the last decade or so that not only, just the mismatch of languages and the number of languages you need to deploy to actually get something done in a real world project seems to be going up. And I don't know if that's just me or if everybody's seeing that same thing. So I thought I'd ask.
Yeah, we had C++, C#, Node.js, JavaScript, TypeScript,
Okay.
and other things.
I do see a little bit of mixing and joining with C++ and Python. The spot where all the other languages hit me is in the build system. Everybody uses their favorite scripting language. One guy awks it, and the other guy seds it, another guy runs it to a Python script, and another one runs it through CMake, and build all these things, just baling wire, bubblegum together. And it makes for a very, very fragile system. And then they plug it inside of Jenkins or something else. So,
yeah, I initially wasn't even considering the build system, but you're right. We're doing that too. We've got Python in the build system with both make and CMake. So yeah, that's also true. Okay, that was just an interesting.
Yeah, I know the place before the current one, before it got bought and everything moved to Minnesota, which I decided I didn't want to do. Let's see. Oh yeah, add Cypress PSOC creator.
Yep.
And yeah, there were a lot of there's Ruby, C++, C, probably some Python. Yeah, there was some Python.
Okay, so it's not just me.
No.
Interesting. Because it really, at least what I'm seeing is the effect is it really drives up the complexity of the project. At least in some cases it helps, but in some cases it makes it much more fragile. And when you go to maintain the project, I've been around for quite a while, and so it's like I've had time to learn all these languages. But new people coming in, or the younger generation of programmers, not only do they have to learn C++, for instance, which is considered moderately challenging, they've got to learn all these other languages too.
Yeah.
So you either get stuck with more senior people or a collection of less senior people, just to cover the base. And
so
go ahead.
What seems hard to me is how do you debug that kind of stuff, right? Like I've always been a systems programmer, and it was basically just C++ and assembly language, and the Visual Studio debugger just handled it perfectly, right? But then if you have 5 different layers, all in different languages, like what are you going to do?
What I see most people do is printf.
Yeah, that's what I've come to now as well.
Yep.
and embedded, there's all those wiggling output pins, but that's not generally useful for probably what you're doing.
Oh no, I actually do that too. If I'm on the microcontroller in C, I generally put a debug library in there so I can toggle GPIOs.
Yeah.
And I specifically use that for a lot of what I do is real-time processing.
Yeah.
And hard real-time processing. So the GPIO toggling a bit and looking at it on a scope is very critical to doing any of that work.
Right.
Okay. Any other thoughts or comments? Peter, if you could send me your slides, and Chris already disappeared. I'll get the slides from him. I'll get the slides posted with the video. And
sure, I'll send my slides.
Say again?
Sure, I will send my slides.
Okay, thanks. And what did people think of this? Would you guys like to do it again? Was this fun?
I thought it was great. At first, it looked like there was just going to be 3 5-minute presentations, but it stretched out to the whole hour because everybody was into it, asking questions. I think once a year isn't even enough.
I tend to agree with that.
I'm looking forward to seeing it because Teams decided to choke and I had to reinstall it and reboot.
Oh, no. Okay, I will put this on the docket at least once for next year, maybe in like 6 or 8 months. And if we get enough people, we'll just do them, keep cycling them. Okay, just a final reminder, no C++ or Northwest C++ meeting next month. Please feel free to play at CPPCon. And we'll be back in November. And everyone have a good October.
Oh, you too. Thanks so much for hosting.
Yep.
Thanks.
Oh,
Indeed.
and of course, if you do want to do a presentation for next year, I'm starting to book those. So if you want to do a longer presentation, please let me know on that as well. Okay, Robin, I guess we can go ahead and stop the recording at this point.
All right. Thank you very much, everybody.
Yep. Thanks.
All right.